The results of our test might feel disappointing. The actual difference between the means of our samples is quite large at almost 13%. Over a year, a difference of 13% could be a lot of money. But our test, using the sample size we had, wasn't sensitive enough, so we can't be confident this difference actually exists. What went wrong here? Earlier, we talked about how sample sizes over 30 are generally good enough, though samples of 100 are much better. We're working with a sample size of 750, so shouldn't that be pretty sensitive? Recall that in some situations, we may need much larger sample sizes. One such situation is when there is a low rate of positive cases. If you examine the observations in our data, only about 10% of visitors end up purchasing a vacuum. That means our samples are being determined by about 75 individuals, so there is a fairly low rate of positive cases. Not only that, but within those 75 or so individuals, there's a lot of variance, with some buying the vacuums for half off and some buying 2 or 3 vacuums at full price. Our average standard deviation is $174. A high variance and a low rate of positive cases can really hurt the sensitivity of our test. In hindsight, we probably should have looked at the historical conversion rate of our customers when determining our sample size, or looked at industry averages for an estimation of what to expect. If we had expected a high variance and low conversion rate, and we knew we wanted a sensitive test, we might have known to pull a larger sample. Even though we didn't reject the null hypothesis, the best practice is to still report these findings. For our next step, we should not pull a new sample of the same size and redo the test to see if we get a different result, or go back and remove outliers to try and make it significant, or change up the variables, like looking at only results from the US. Or if our result is close to our alpha but not quite small enough, we don't want to add 2 to 3 more observations to see if it changes. These are all examples of p-hacking, and these actions dramatically increase the chance of a false positive. Of course, we may want to try this experiment again with a more sensitive test. In Chapter 5, we'll explore how to do this properly by first doing a power analysis.